Another new topic we have in grade 11 for analytical geometry is our inclination or angle of inclination, which firstly you need to know an angle of inclination is always between a line and the positive x-axis. So if this is your positive x-axis, the angle of inclination will be from here to that line. That will be your theta. And it can be any type of angle. It can be acute angle, right angle, obtuse, straight line, whatever. But we usually work within 0 to 180. And it's measured anti-clockwise, sorry. So it's from here to the line. Then this is our formula we have for inclination, but it's also a formula for gradient. And it is tan theta equal to m. And then obviously if you want to find theta, you will use arctan and substitute in there your m. M, your gradient, can be a number, but it can also be a ratio. Well, a number in itself, like a whole number is also a ratio. But anyway, if m is a positive value, then you're going to straight put that in there and you get your answer for the angle. If it's a negative value and you put this in your calculator, then you will see you get a negative angle. That is because, okay, so a negative gradient means basically it's going to form an obtuse angle, right? It's a descending straight line. So you are looking for always between the x-axis and the line. But what you are calculating, if it's a negative value, is actually it goes and finds the acute value. So for example, you might get negative 45. That's because, remember, our cast, whatever, negative angles are here in the fourth quadrant. Okay, so it's actually the size is 45, but negative because of the negative direction. So all that you are going to do whenever it gives, so if you put a negative value in there, or if it gives you a negative answer, depends on when you remember, you're just going to add 180, because if this is negative 45, because of angles on a straight line, this is going to be 135. Okay, that's what you need to know. And then this is just like a summary. If it's a positive gradient, like a positive ascending straight line, you'll get an acute angle. If it's a negative or descending straight line, you'll get obtuse. If it's a horizontal line, 0. And if it's a vertical line, you'll get 90. Okay, so we're going to determine the inclination of line PQ in each of these cases. So to find inclination, you need a gradient. You are not given a gradient here, but you have 2 points, so you can find your gradient. So that's your first step. You go find your gradient. I would always put the 0, 0, 1 last, just because that makes the calculations easier. And then your answer is 1 over square root 3. Then, now you have your gradient. You want to go find that angle over there. So you're going to say theta is arctan of 1 over square root 3. Or, of course, you could have started by saying 1 over square root 3 is equal to tan theta. And then you can do your arctan story. This is going to be an acute angle because we're working with a positive ratio over there. And you'll get your answer as 30 degrees. So this angle over there is 30, meaning this one would obviously be 60. Those are all things that you're going to have to keep in mind because questions like this are usually asked within bigger questions. But we'll get to that at some point in the future. Okay, we just need to do our basic stuff first. Then, with this question, you are allowed to move, you're not actually moving the x-axis, but drawing a line that's parallel to the x-axis there to that point, just to make it easier for you to see we're looking for that angle. And the reason you can do that is technically if this line was extended, blah, blah, imagine this is now beautifully drawn with a ruler, then you are actually looking for this angle, right, between the x-axis and the line. Because these lines are parallel, you specifically draw it so it is parallel. That's most corresponding angles, and corresponding angles are almost equal. Okay, so we're going to be looking for this angle over there. Again, first we were not given a gradient, so we have to go find it and calculate it. Okay, you get -1. So you go substitute it into your formula. So theta is going to be arctan of -1. And you're going to see you get -45 when you put this into your calculator. So you just need to remember the -45 would be this angle over here. So you go add the 180, and then you should be getting 135. Okay, here we have some more questions on angle of inclination, but now they get very wordy. We need to get comfortable with that in maths. I know we don't like it, or oftentimes we don't like it, but you need to get comfortable with that. So, determine the inclination of a straight line. There they give you a straight line. Correct the 2 decimals. Okay, so you already know it's not going to work out nicely. Bear with it. So, firstly, to put into our formula, we need a gradient. We don't have one, but we can get one by making sure this is in standard form. You cannot just say, there's a 3 in front of the x, so it's 3. It's not. So, you first take over your 3x by subtracting 3x, right? And then you have to still divide by 2. So -3 over 2x plus 5 over 2. Remember to divide the 2 by every single term, right? Then, now we have a gradient, okay? Standard form is important. So, your theta will be arctan of -3 over 2. You already know it's going to give you a negative answer, so you quickly just plus 180 on your calculator, and then you can go on with your life. And this is what you should get. One more, and then we're done with this video. Determine the equation. Okay, this is a different type question. They're asking for the equation of a straight line. So now you already know this is an equation of a straight line. You need a gradient, and you need your y-intercept, which you can get by a point. So you need a gradient and you need a point. With an inclination angle of, okay, so they gave you the angle of inclination, meaning you can find the gradient that way, and they give you a point. So we first have to go find our gradient, which is going to be tan of 135. You don't have to do the subtract 180. Tan repeats every 180 degrees, right? That's the period of tan. So it's already built into it. It will give you a negative answer when you put it in your calculator. And you get -1. Okay, so again, I'm just going to say it again. This is an obtuse angle. Here, an obtuse angle is a negative, and you had to go add the 180. You don't have to do that because your calculator takes into account the tan has a period of 180 and it repeats every 180 degrees. So it's already built in there. Don't worry about it. Okay, now we have a gradient. We have a point. Go substitute. And again, it's nice if you use your new formula that we did. Okay, remember this -1 has to be multiplied with each term, so it's going to change that sign. And then the -2, you get to the other side by adding 2. So your answer is -x plus 5. Okay, and it makes sense because it has an obtuse angle. So you have a negative straight line with a negative gradient. So yeah, and then you can go on. That's it for now.